Question 2 says, the template strand of a piece of DNA being replicated reads from the 5' to 3' direction, ATAGGCCGT. A partially synthesized fragment from the lagging strand is 5' CCTA to 3'. If the next fragment is 4 bases long, what is its first base? Show a diagram of this process and explain. Okay, so first thing to understand is what we've been given in that first line is the lagging strand, right? Because it's from 5' to 3', so that's the lagging strand. Remember, in general, on DNA replication, you've got two sides that run opposite each other, and the one that's the 3' to 5' can open in the same direction as the helicase, so we call that the leading strand. And the one that's 5' to 3' opens in the opposite direction, or copies in the opposite direction as helicase, so we call that the lagging strand. Okay, so if we're saying it's being replicated and it reads 5' to 3', that means we're talking about the lagging strand here. So we've got to imagine this lagging strand has bases like this on it, going in the correct direction from 5' to 3'. Okay, so that's what that first line is saying. The second line says that we've already copied a portion of that lagging strand, and we've got a chunk or an Okazaki fragment from that copy. So we're not worried about what's going on in this leading strand at all. Okay, I'm just asking about how does that lagging strand copy? The 5' to 3' direction is important in this because the 5' end of this new fragment needs to line up with the 3' end of the old fragment. So I'm going to do this new fragment in blue. The 5' end of the new one has to be this side, and the 3' end of the new one has to be on this side. So CCTA, then, from 5' to 3' lines up right here, CCTA. Again, reading from 5' to 3'. So this was the fragment that was made. And again, look at the direction of this lagging strand. The CCTA was put down in this direction. Okay? So that's what we've copied so far. But we haven't completely copied that strand. There are still some pieces of the white that haven't been replicated yet. So it says if the next fragment that it does is 4 bases long, what is its first base? So this is the lagging strand. If it finishes going in this direction, okay, it's going to finish this fragment, right? We know that's going to happen. We want to know, though, what happens for the next fragment. So now it's at the end of this strand. Because it's the lagging strand, it has to back all the way up and come right here and start to do the next 4 bases, which are going to be A, C, G, G. So the next 4 base fragment is A, C, G, G. What is the first base is what the question is. The first base is going to be right here. First base is A. Okay, so the whole idea behind this question is understanding leading versus lagging strand and how that works in the 5' to 3' direction. And then also some of your base pairing rules. T's pair with A's, A's paired with T's, G's paired with C's, C's paired with G's, so forth and so on.